Assalamualaikum. Hi everyone. Alright, so today I'm going to discuss about sp2 hybrid orbital. Right, so sp2 hybrid orbital can be defined as mixing one s orbital with two p orbital. So it will form three sp2 hybrid orbital, which three electron pairs. All the three electron pairs are arranged according to the shape of trigonal planar with the bond angle over 120. So we can see from this diagram, one s orbital mixed with two p orbital, right? It will form three sp hybrid orbital. Okay, now we take a look at the example then. Alright, so the first example is pH3. Alright, so the first of all, you have to draw the Lewis structure. Don't forget to calculate the total number of valence electrons. So this is the Lewis structure. From the Lewis structure, you have to identify the class. Since there are 1, 2, 3 the bonding pair, so therefore the class of compound is AB3. Okay, so the shape for AB3 here is trigonal planar. Okay, the bond angle here is 120. Alright, so you can write the explanation like this. The molecular shape of PTH3 is trigonal planar. Okay, the bond angle of 120. Okay, the next step, you can identify the type of hybridization. Right? So since there are three sigma bond here and no lone pair at the center atom, so there are three electron pairs. Okay, and the type of hybridization is sp2. Alright, so the three electron pairs are arranged according to the shape of trigonal planar. Alright, okay, next we move to the orbital diagram. So we start with the center atom, boron, at the ground state. So we already know boron has three valence electrons. So at the ground state, it only has one paired electron and one single electron. So meaning that it can form only one sigma bond. From the molecular shape, you want to form three sigma bond. So that's why one of the electrons from 2s is promoted to 2p. So you can write the explanation like this. At the ground state, boron can only form one sigma bond. Therefore, one electron is promoted from 2s to 2p orbital. Okay, and it will form excited state. At the excited state, there are three single electrons. Okay, in order to form three sigma bond. However, at the excited state here, or the electron is unstable, so the orbital have to mix two s orbital will mix with two 2p orbital, and it will form three sp2 hybrid orbital. Right, so how that you can explain? So we can explain like this, mixing one 2s orbital with two 2p orbital form three sp2 hybrid orbital. And we can see here at the p orbital, we have empty orbital. And you have to write it down for the hybrid state. Okay, and label empty orbital. Okay, right, so next, write the orbital diagram for the terminal at the ground state, which refer to hydrogen that has only one valence electron that is located in one s orbital. Okay, now we take a look at the overlapping. Okay, so we can see clearly here that the sigma bond is formed when one s orbital of hydrogen is overlapped with sp2 hybrid orbital of boron. Okay, so you can write the expression like this: overlapping one s orbital of hydrogen with sp2 hybrid orbital of boron forms sigma bond. Now we move to the orbital overlap. Right, so you can use the molecular shape as the reference to draw the orbital overlap, since the shape for sp2 hybrid orbital is trigonal planar. Okay, so it's better if you draw the sp hybrid orbital first. Okay, it should have three sp2 hybrid orbital. Okay, so sigma bond is formed when sp hybrid orbital overlap with one s orbital of H. So you have to draw spherical shape. Okay, then forget to draw the electron and label sigma. Alright, next, you have to label the rest, which means this one S, okay, and this is sp2. Alright, and then don't forget to label the atom, okay, and the center here is boron. Okay, so that is for the first example. Now we move to the second example that refer to CH2O. Alright, so the first step, you have to draw the Lewis structure of CH2O. Don't forget to show the calculation for the total valence electron. And here is the Lewis structure. Now, we want to identify the molecular shape. When we refer to the Lewis structure, we have two single bond and one double bond. So double bond here is counted as one bonding pair. So we have one bonding pair, two bonding pair, three bonding pair. So the class of compound here is AB3 and the shape here is trigonal planar. The bond angle here is 120. So how that you can draw the trigonal planar shape? So boleh lukis dua. So like this. This one. Also we call it trigonal planar. Okay. Ataupun macam ni. Bentuk macam ni. Pun boleh. Okay. Now to explain. Alright. So the molecular shape of CH2O is trigonal planar. With bond angle of 120. Okay. Now we want to identify the type of hybridization. So we have to refer back to the molecular shape. So for this one, we take a look at the bonds. The single bond consists of sigma bond. However, for the double bond consists of one sigma and one pi. So when we total up, there are 1, 2, 3 sigma bond. So therefore, there are 3 electron pair located at the center atom. Okay, therefore, the type of hybridization is sp2. All the 3 electron pairs are arranged according to trigonal planar shape. Okay, now we move to the orbital diagram, step number 4. Okay, so first we have to write orbital diagram for the carbon center at the ground state. Carbon have 4 valence electrons. So therefore at the ground state, there are 1 paired electron and 2 single electron. Okay, when we refer back to the molecular shape, we want to form 1, 2, 3 sigma bond and 1 pi bond. So which means it should have 4 single electron. Single unpaired electron. Alright, so that is why at the ground state, a carbon can only form 2 sigma bond and cannot form pi bond. So therefore, 1 electron from 2s is has to promoted to 2p. So you can write the explanation like this. So at the ground state, carbon can only form 2 sigma bond. So therefore, 1 electron is promoted from 2s to 2p orbital and it will form excited state. Okay, at the excited state, there are 1, 2, 3, 4 single unpaired electron in order to form 3 sigma bond and 1 pi bond. Okay, now the excited state is unstable, right? So we have to mix one s orbital with two 2p orbital in order to form sp2 hybrid orbital, which means it has 3 sp2 hybrid orbital. Okay, as we can see here, they still have one valence electron located in 2p. You just write it down at the orbital diagram for the hybrid state. So for this 2p pure orbital here, so the function here in order to form the pi bond. Okay, next, you have to draw the orbital diagram for the terminal. We start with hydrogen. So hydrogen, they have only one valence electron located in one s. As for the oxygen, okay, now we take a look at the overlapping. So apa yang overlap dengan apa? For the sigma bond, we take a look at the sigma bond. So sigma bond is formed between carbon and hydrogen and between carbon and oxygen. This one, eh? Okay, so two sigma bond is formed between one s orbital. Okay, this one, one s orbital overlap with two sp hybrid orbital here. Okay, we highlight this one, overlap with two sp hybrid orbital. So this one in order to form two sigma bond. Okay, the third sigma bond is involved between the overlapping of 2p pure orbital of oxygen with sp2 hybrid orbital of carbon here. Okay, so third sigma bond. For the pi bond, so is formed when overlapping of 2p pure orbital of oxygen with 2p orbital of carbon. So in order pi bond. Okay. Now we want how that you can write the explanation. So this is sample explanation. Okay, so overlapping 2p orbital of oxygen with sp2 hybrid orbital, we form sigma bond. Okay, and then overlapping of 2p orbital of oxygen with 2p orbital of carbon. So it forms the easier way to draw the overlapping of pi. So we can choose this shape. This is more easier. Okay, so first you have to draw the sp hybrid orbital, sp2 hybrid orbital. Alright, next, okay, the sigma bond here is formed between sp hybrid orbital with 2p orbital of this one, ni overlap with 2p orbital of oxygen. Okay, so the first sigma bond here. Okay, so we can draw the other two sigma bond is formed between overlapping of one s with sp2 hybrid orbital. Label sigma and label the rest. Okay, so we have done for the sigma. Now we want to draw for the pi bond. 2px, 2px overlap with 2px. Okay, and then you have to label pi. And then forget to draw the spin up and spin down. And finally label the atom. Hydrogen. This is carbon. This is oxygen. And one more thing we have to label here is 2p. Okay, so we have done.